Hello everybody, and in today's topic summary for Leaving Cert Higher Level, we're going to look into a bit of probability. For probability, I've split it into 5 different subsections, and we're going to go through them in due course. So the first one we were looking at is arrangements, and with arrangements we have 2 types of arrangements that you would have looked at. Both permutation, where you would have used the NPR button on your calculator, where the order is important. An example of that would have been arranging a word using specific letters. The second type of arrangement that you would have had is combinations. You would use the NCR button, and the difference there is the order is not important. So for example, if you had a committee of males and females, or another everyday example of combinations would be the lotto numbers, where the numbers come out, but it doesn't matter what particular order they come out on. Okay, that's the arrangements, and as I said, the key is to know whether to use permutations or combinations and whether the order is important or not. The second section is the rules of probability. You will have seen some of them in junior cycle, okay, and we're just going to go through them. So the first very fundamental rule of probability is the probability of an event occurring is the desired outcomes over the total number of outcomes. An example there is what would be the probability of being born in December, which would be 1 month out of 12 months, so it would be 1 over 12. The sum of all probability events equals 1. Okay, and the probability of an event not occurring is 1 minus the probability of the event occurring. So for using our December example, the probability of being born in a month other than December is 1 minus 1 over 12, which will be 11 over 12. So there are 3 of the 5 major rules of probability. We're going to look at the last 2 in a moment, but we need to be able to solve using both Venn diagrams and tree diagrams. Okay, so Venn diagram set theory you would have seen in junior cycle. So A union B, A intersection C. So we'll need to be able to use that knowledge to solve some probability. So the probability of one event occurring and a probability of a second event occurring, we multiply the 2. So what's the probability of being born in December and on a Monday? Would be 1 over 12 multiplied by 1 over 7, which will be 1 over 84. So it's important to see the word and there. And represented on a Venn diagram is the intersection region. So something where 2 things are intersection, it's E1 intersection E2. Then the other option that we could be asked is what's the probability of event 1 happening or event 2 happening. An example would be what's the probability about being born on December or November. So it'd be 1 over 12 plus 1 over 12, which would be 2 over 12. In this case, it would be, how that would be represented on a Venn diagram would be E1 union E2. If they're mutual exclusive, it would mean that the probability of A plus the probability of B would equal PA union B. Mutual exclusive means that they won't happen in both. Certain events can happen in both. So non-mutual exclusive is P, the probability of A union B is the same as probability of A plus the probability of B minus the probability of A intersection B. So for example, in a deck of cards, if I ask what's the probability of getting a queen or a heart, you would have 13 hearts, 13 over 52, plus you have your 4 queens, but you also have 1 card in the deck that is both a heart and a queen, so that would be 16 over 52. So sometimes events can happen in both A and B. Okay, so conditional probability is written PA/B, which reads in English as what's the probability of B on the condition that A has occurred. So the formula we will use is P is the A intersection B all over the probability of B occurring. Expected value is used in games. So for example, is it worth playing a game or not? The formula will be E of x, the expected value is x, which is the sum of the outcomes multiplied by the probability of that particular outcome. And the fifth and final section that we're going to look at with probability is Bernoulli's trials. Bernoulli's trials is quite important there, and some of the characteristics of Bernoulli's trials are, first of all, it has to have a fixed amount of trials. So they will tell you exactly how many trials it will have. It doesn't go on to infinity. There's only two outcomes here, success and failure. Trials are independent of each other, so it will have the same success for each trial. So there are the characteristics. So here's the formula: NCR, P to the power of R, Q to the power of N minus R. So P is success, Q is failure, N is going to be your total amount of trials, and R is your success of how many trials you have been successful in. So three different types of questions that you will be asked with Bernoulli's trials. The first is the first success after N trials is simply P by Q to the power of N minus 1. Not a bad one. The second one is if we've had R successes after N trials. So for example, if I had played basketball and I successfully shot the hoop 7 times out of the 10, it doesn't matter where those 7 occurred, we would use the formula NCR by P to the power of R by Q to the power of N minus R. And then the last type of question, it looks quite similar, is to find the Rth success after N trials. So an example would be if I asked you to find the 5th success is on the 8th trial, it means that the last go has to be a success. Whereas in the second one here, it doesn't matter where the successes and failures were. If it says that the 5th success has to be on the 8th trial, we will use the formula like so, which is P. We know that for the first 7 trials you had 4 successes, and then you multiply that by the success of an 8th trial, which would be 7, choose 4. 7, choose 4, by P to the power of 4 by Q to the power of 3, and then you had P as your success of your 8th trial. Just underline that represents the P. I'll get another little marker, and then your first bit there. Then you use your laws of indices. P to the power of 4 multiplied by P becomes P to the power of 5 by Q to the power of 3, then 7, choose 4 to get your solution.